Hello, everyone. My name is Uriel Antonio. I am a robotics engineering alum at UC Santa Cruz.
Hello, my name is Erwin Jimenez, and I'm a recent aerospace engineering graduate from UC Davis. We both interned at AgXactly this summer. AgXactly is an agriculture informatics company that helps farmers reduce crop loss rates and therefore also helps them save money. AgXactly achieves this by using aerial imagery and also with proprietary algorithms. Drones are reestablishing traditional farming by using precision farming, which is the way that farmers manage crops to ensure efficiency of water and fertilizer. It is also the way that they maximize productivity, quality, and yield rates. To the right is a picture of how drones can use infrared sensors to capture crop status. Every field farm is different from the type of crop to the environment it grows in. Each farmer has specific requirements for their crops to thrive. The big picture in our project was to design a custom drone that can adapt to any type of field and can use any type of sensor, such as infrared, LiDAR, or typical RGB cameras. With this custom drone, we will be able to help farmers and increase volume of food in our food supply chain. It is easier to create a drone that has specific purpose than a drone with multiple abilities. While designing this drone, an important factor was choosing between longer flight times or heavier payloads. The problem is that sometimes farmers have to walk through fields to get rid of unwanted crops. In the picture on the right, a biologist is seen doing this. Our drone's purpose was to make their jobs easier.
So our first step for this research project was to take aerial images of a strip of land and to be able to see whether or not we could detect physical differences between the unwanted crops and the rest of the vegetation. So as we can see here on the bottom left, we have Graham, our flight coordinator, as well as Erwin working on a VTOL aircraft, which is one that was used to take some photo images that day. So as we can see on the photo on the right, we were able to successfully detect physical differences between the unwanted crops and the rest of the vegetation. We have a lighter hue of green on the unwanted crops, as well as a different height profile. So this led to drone research, right? After we knew we were able to successfully detect these unwanted crops, we needed to determine the capabilities that our custom drone needed to have in order to successfully identify them. This led to cost analysis, which we brought up to AgXactly, and led to our drone build. In order to further help farmers identify these unwanted crops and go out and take them out from the field, we need high precision RTK and or PPK capabilities, which we would have to replace and not use GPS because it's not something that is precise enough to tell centimeter accuracy where these unwanted crops are in the field. We would also like to have GPU integration for deep learning systems, which would require some sort of Raspberry Pi to take some of the load off on the flight controller that is aboard the drone itself, as well as extend our flight times. I really enjoyed this experience with working with AgXactly because I was able to understand what it takes for an autonomous drone to fly, as well as learn the different applications our drones have in the agricultural sector.
For me, it was rewarding to apply my aerospace knowledge to the food supply chain, something I thought would never happen, and this was done all through using drones. Thank you to our mentors at AgXactly and to CITRIS for giving us this opportunity.
I'm Dylan Davis, a current third year majoring in computer science and economics at UC Berkeley. And this summer I worked with DiamondStream partners on a project titled Secular Trends in Aviation. The goal of this project was to analyze aviation disruption potential thanks to new developments in the aviation industry, specifically smaller aircraft with shorter effective distances enabled by new technological advancements, including hybrid electric propulsion as well as autonomy. The goal of the project was to understand how these smaller aircraft with shorter distances could potentially disrupt current modes of ground transportation for both goods as well as people. In order to determine where this disruption could come, I had to do an analysis of cost structure for vehicles both in the air as well as on the ground. When doing an analysis of each vehicle, some of the things I had to consider included effective range as well as average cost per seat mile in order to determine the optimal use cases for each vehicle. When examining a use case, I had to determine whether aviation had the potential to disrupt the existing ground transportation option, or whether ground would remain the predominant mode of transportation. Some of the challenges I faced over the course of my internship included working with incomplete or unreliable information and still being able to draw conclusions out of the data that I had. I learned that while ground might remain the predominant mode of transportation for some use cases, aviation definitely had the potential to disrupt ground modes of transportation, especially at more mid-mile ranges. Moving forward, I think some of the key things to understand is that aviation is entering a new age, and in looking towards the future, there has to be a focus on areas best suited for aviation, as well as an understanding for how society has the potential to change thanks to these new developments. There also for DiamondStream as an investment firm, they have to understand which companies will succeed and why in this new climate, and which ones will fall behind. I'd like to thank Tracy for her guidance throughout this whole project and for really mentoring me throughout this whole process. And I thought it was a really great experience.
Hi, my name is Connie Guzikowski. This summer, I interned at the Environmental Defense Fund for the Climate Smart Ag team to research robotics and agriculture and the environmental benefits that they bring. So we must ask ourselves, why should we bring robotics into agriculture? What benefits do they bring? Well, for starters, robotics can increase the plant soil health on farm. They can protect the water supply, control pests, diseases, and weeds, reduce emissions and labor-intensive jobs, and increase speed and efficiency. We're going to go over a couple of robotics applications. There are a large variety of different robots being used on the field today, but with my limited time, we're only going to cover two. The most common of which being the robotic sprayers, which are used to spray herbicide, pesticide, and or fertilizer. They are claiming to reduce spraying by 90-95%, lowering overall emissions, making sure that the correct crops are being sprayed, and protecting the water supply by not letting any of the spray get into it. Another common form of robots on the field are drones, which are mainly used for surveillance now. They use cameras to gather information to report back plant and soil health. This allows farmers to detect where pests, diseases are and make it so that they can't spread. It also helps let them know more accurately what techniques are working. There are currently sprayer drones in development, which act as spraying tractors, but they fly and don't compact the soil, which bring environmental benefits. So now we must ask ourselves, well, why not? Well, first of all, robots are very expensive to buy and maintain, and that can be a little bit discriminatory towards smaller farmers. So companies luckily have been making cost-efficient methods, and as robots become more and more prevalent in agriculture, then the cost will naturally just go down. There's a concern that jobs will be automated away, but with robotics, new jobs will also come in maintaining and operating the robots. These will be very less demanding and less discriminatory jobs. There's some legality issues for drones, such as getting licenses, depending on where you are, and different areas need different licenses to fly. And a big problem with robots is that they're not sophisticated enough for all agricultural tasks yet, which makes it so they can be very expensive and also very slow. Now, I would like to thank you to CITRIS and EDF for this great opportunity to research robots in agriculture. I had a very great time, and I found it exciting to research emerging technology. Thank you.
Good evening, everybody. My name is Assan. I am a senior majoring in aerospace engineering. Today, I am presenting as part of the Workforce Innovation Program as a wildfire flight test intern in the Department of MAE at UC Davis, where my project today will focus on a Nimbus VTOL technology in wildfire applications. Here's the big picture of what my internship project entails. I am investigating autonomous mapping and surveying in remote locations. Our biggest stakeholders as of now are local fire crew and fire departments, where they have a small drone department or team that can set out for remote locations as wildfire season concerns are the highest in the summer around here in the West Coast. This drone technology provided by Foxtech is able to support pre-event detection, in-event mitigation, and also post-event analysis. And to do this, we have a local flight area where we can investigate our autonomous waypoints in live as they go, and also validate what our software in the loop simulations are occurring. This is beneficial as fire crews also are interested in assessment or even possibly rescue depending on the payloads. As an intern here, I've worked in a drone lab and also field testing. Most of my duties include pre-flight checks and troubleshooting of the mission planner and Pixhawk controlled VTOL, which switches from multi-copter to plane. I've also looked into payload selection for camera gimbals and also perform software in the loop verification validation in the lab, and also in the pictures below where we have to configure all these checks before a mission can take place. There are some sets of future work as my internship wraps up. There's also risk assessment for dangerous and dynamic situations fire crews might encounter. Additional thought into autonomous mission design using Mission Planner. We've also briefly touched upon black box log analysis, such as vibration analysis to make sure the craft is stable, and also hardware and payload selection for the tablet and also the camera gimbal. I would like to thank everybody at the Workforce Innovation Program, and also thanks to my team, Nate Messler, our supervisor, Jason, Whitney, Lily, and Emerald. Thank you for listening to my presentation.
Hello, my name is Liliana Figueroa. I go to UC Davis. I'm an aerospace engineering major. I'm currently a senior, and I intern at the UC Davis CITRIS lab. We'll be talking about improving drone communication for wildfire detection and prevention. The big picture or the overall issue is that massive wildfire risks are increasing every year. Annual wildfires and acres burned are shown here in this increasing but steady trend in this chart. And every year, the wildfires becoming even more destructive. Most notably, in 2021, the Dixie Fire was the largest recorded fire ever in California history. In 2018, California wildfires cost the U.S. economy billions and billions of dollars. So wildfire is a huge issue that involves everyone and affects everyone in their livelihoods. When speaking with firefighters, they said that the main issue in their work was communication or lack of communication because they work in remote areas. And lack of communication affects resources, fire progression, personnel, firefighter and civilian safety, and of course, early fire detection capabilities. So the current market trends for early fire detection and wildfire propagation are watchtowers, satellite, optical, and of course drones. However, these all have slow and unreliable data relay. And so we want to improve more specifically drones communication capabilities or optical drone capabilities and providing data to firefighters in an effective and quick real-time way. So in order to improve the reach of these optical drones and their infrared imaging cameras is to have them integrated into a sensory node network. And this sensory node network is part of a separate project, but in collaboration with this drone project. And we wanted to see whether drone communications are improved by having it be interface of this sensory network and act as a node in the sky. Now, one of the issues in my role in this project, and one of the learning curves is learning about antenna design or antenna theory and communication. theory, and that involved designing a couple of antennas in a software program and testing its radiation pattern and see how efficient and effective those designs are. And these are for the nodes and for the drones. Another thing that I had was part of the project was creating a belly pod that would carry a communication system that will allow us to interface with the sensory node network in the drone. And all this is to hope that we could improve the communications with a drone, with an optical drone, and have sent its optical data down to the sensory node network. So one of the next steps or future steps for this project, which I will be a part of, is to continue research of the sensory node network that's a part of the startup, and to continue research of the drone and node network interface and do in-field testing that will involve controlled burns and to see whether the drone's communications capabilities is improved. Special thanks to Nathan Mitzler, who is the UC Davis CITRIS director, Jason Whitney, who is a graduate student, is Jason Assan, who was also part of this project and another intern for the CITRIS program. Thank you.
Hello, my name is Javier Wally. I'm a third-year mechanical engineering major at the University of California, Merced.
Hi, my name is Kayla Cunningham, and I'm a second-year double aerospace and mechanical engineering major at UC Davis.
Today, we'll be talking about the liquid hydrogen fuel station that we designed for in our internship with Hydroplane. The goal of this internship is to be able to come up with a liquid hydrogen fuel station by determining its processes and equipment that will be used to fuel the aircraft. This is important because liquid hydrogen is a form of sustainable and renewable energy that is also a solution that will help reduce the amount of carbon emissions that modern-day aviation produces. In addition, it also addresses the problems that battery-powered aircraft have, such as limited range, low payload, and low operational efficiency. The challenges that I had to resolve around are finding and assessing products that will be used for the LH2 system. When looking at the bigger picture, designing an LH2 system is something you cannot do from scratch without knowledge or assistance. Here, I reached out to companies, organized meetings, research requirements, and made a product list and made diagrams to have a better understanding of what is needed for an LH2 system. From this, I learned the benefits of networking, like building relationships in the business setting and asking questions to have a better understanding of the task that I am performing. I also learned that taking notes is important. I took many notes about the new things I learned, the feedback I received, and the goals that I wanted to meet. This allowed me to reflect on myself and made me notice my overall growth, as well as the areas that I wanted to improve on.
So to design the liquid hydrogen fueling station, we first need to do a lot of research on existing gaseous hydrogen stations and on liquid hydrogen handling techniques. So after this, we got an idea of what components we needed for the system, and were able to create a block diagram and a system requirements tree. Once we had an idea of how the system would run, we then needed to create a real-life layout of the system. We researched safety requirements for liquid hydrogen and vendors for the components that we needed, and were able to create the CAD diagram that you see on the right. So the basics of how the system works is that we have this cryogenic pump here, and this will pump the liquid hydrogen from the storage tank to the fueling station. And on the fueling station, there's a hose and a nozzle that will connect to the aircraft, which is parked in this designated parking space. We then have components like the air compressor and nitrogen storage to support the other components in the system. So once we had this, we were able to create a thermal model for the system. And to wrap up the project, we created a CONOP procedure and safety requirements for the normal operation of the procedure. Throughout the project, I learned how to effectively manage a project from start to finish, how to collaborate and communicate my ideas, and how to persevere and iterate ideas to create the best solution for this project. So the future improvements for this station would be to implement new products into the system. So hydrogen is a rapidly growing industry. So in the future, there will be even newer and better products to implement on the system. And the next improvement that we were thinking of implementing is a hydrogen fuel cell battery backup. So we can capture and store the liquid hydrogen boil off in a separate container, use this gaseous hydrogen and a hydrogen fuel cell to create electricity for the system. So that way, if there's a blackout, the station still has power. And the final improvement to be made would be to find a control panel and to write a program to control the system. This is a critical component and must be implemented before the station is operational. Finally, we would like to thank Dr. Anita Sengupta for her help and guidance on this project. And thank you for listening.
Hello, my name is Napshi Budamatia.
Hi, my name is Angel Delatorre, and this is our presentation for the CITRIS Workforce Innovation Program. And the sector that we were interning at this summer was the sector of aviation. So in terms of the company that we were interning for, the company was JetZero. This company had us working on the mobile operations center for them. And we're going to go into a little bit in depth about what that was and sort of what the company is about. So in terms of the big picture motivation of the problem, the JetZero is aimed at creating the next generation of commercial airliners. Right now, they're currently working towards creating fuel-efficient airliners as well as their mission, and they're doing this in response to the climate change and rising greenhouse gas emissions, which is leaving us with little to no room to adapt in order to address the climate crisis.
Some of the technical contributions and learning things that we were experiencing at JetZero was one and mostly 3D modeling using Fusion 360. We also helped manufacture aircraft models and design certain components to go on them. We did trade studies, joint analysis, and how to start a design using skeletons and to size different equipments and designs using those skeletons and joint analysis as well. And we also learned how to use a weighting system for when there's a lot of options out there to be used in the industry. We can choose which one is the best one by defining certain parameters and giving scores to them. Most of the work that we did was involving 3D modeling and using computer-aided design to visualize a lot of the components that we will need to be building in future. The next steps and personal reflections that we're looking to do are improving our CAD skills and our workmanship in the shop, finalizing our finite element analysis for each project. And that's important because those projects need to be able to withstand certain loadings and stresses that are necessary for their functionality. And we'll also continue to improve our organizational and management skills and also delegating working group meetings now that we are tasked with leading certain meetings. Thank you.
Thank you, and as well, so thank you to all our mentors. Appreciate it.
Hello, everyone. My name is Eric Lopez, and I'm studying mechanical engineering at UC Davis. I currently work for a company called JetZero, and my field of work is on reverse thrusters. Let us begin. The problem. I had to design and develop reverse thrusters without negatively affecting jet engine maintainability. Reverse thrusters tend to be very heavy and have a lot of mechanisms that can impede on this maintainability. But the motivation for using reverse thrusters is that it increases the overall safety of the plane as well as reduces wear on the braking system. The challenges. The main challenge is to determine which reverse thruster works with the company's jet engine architecture. We have the door reversers, we have the bucket reversers, and then we have the cascade reversers, and there exists other variations as well. I also had to learn how to use NX Siemens to provide visual aids. Before joining this company, I was more experienced using SolidWorks, but this company uses NX Siemens, and it was a little bit of a learning curve. I also have to learn how to create animation to visualize the kinematics of the reverse thrusters. Basically, essentially animating how the linkages work and how the blocker doors work as well. The learning. So I learned why certain thrust reversers are more effective than others, and this is based on your jet engine architecture. I am more experienced using NX Siemens. Don't get me wrong, I'm still learning, and I am more experienced in creating animation which allow kinematic visualization of the moving parts. Next steps. I'm extending my internship with JetZero, and I'm continuing my work on incorporating reverse thrusters with the company's jet engine architecture. I want to give thanks to JetZero for giving me the opportunity to work on thrust reversers and to continue on working. I want to thank more specifically Raf Diaz for being my mentor. And lastly, I want to thank the CITRIS program. Thank you very much.
Hi, my name is Isabella Elliott. I'm currently a fifth-year student at UC Davis, and I just finished an internship at JetZero this past summer. And today I'm going to be sharing with you the project that I worked on while I was in internship there. So I worked on the emergency descent simulation, which is a simulation of the height, temperature, pressure, and other conditions as an aircraft descends. So this is important because knowing those conditions can really help us prepare in the design of an aircraft for a situation like that. An interesting fact that I learned was that it takes 17 seconds or there's a mandatory 17 seconds where we learned that there's an issue, like a hole, in our case, a hole in the cabin or a hole in the engine. And after learning about that issue, we have 17 seconds to respond because people need a minute to compose themselves to react. And after the 17 seconds, then we can start adjusting for the conditions that the aircraft is going to undergo. So it's important to prepare for those situations. So the technical skills that I learned while working on this project, I learned a lot about mass flow rate. I found myself looking at this image very consistently. There were a lot of derivations with this image, a lot of applications that we used in the development of ours. We used Excel for this simulation in our Excel spreadsheet. So primarily the technical skills I developed were applications of these three equations: the mass flow rate pictured here, the ideal gas equation, and the isentropic flow equation. And the simulation was done using Euler forward stepping analysis. And okay. So while we did an amazing job on our simulation, thanks to Dr. Basberg and the other interns who worked on this project, there is always room for improvement. So firstly, we found that the trend that we would like our graph to work with was not exactly on the correct line. And so we found that while manipulating the hole size, we were much better able to align it with that trend. So there's room for improvement in understanding exactly what the hole size is. There was also a pressure ratio flip while we were, as time carries on, like throughout time. And that was not accommodated for while we were working on this project. And lastly, the cabin temperature gets very, very cold. There's another MDOT equation that needs to be applied to our simulation when this temperature happens, because the current temperature that we have during this descent is not accurate. So I would like to thank Dr. Basberg especially for his help and his guidance and his help during this internship. I've learned an extreme amount from him, and I'm super grateful to have the skills and experience that I do now. I'd also like to thank Christina Orris and Nate Metzler for their guidance in this internship. So this concludes my presentation. Thank you so much for your attention today, and I hope you have a great day.